So this is week 3, and we're finishing chapter 2 about basic electricity. Some of the information here is going to be very critical, so I'm going to go as slow as possible. Have me repeat myself if you need to understand, because chapter 2 and 3 are the core, essential knowledge we need for the rest of the year, which is Ohm's law, power law, resistances in series and in parallel. That's going to be the 4 basic things we need to do for the rest of the semester. The rest is just knowing what components and what do they do. It's much easier, it goes down from there. But chapter 2 and 3 are very important in terms of like scientific things we need to know about electricity that pertain our field. And they are very important, and they are required knowledge. And this knowledge is being verified by people from the field by saying, okay, we need the students to know this because it's important. So we'll recap this stuff mostly we covered last week. What are we going to talk about? We'll explain atomic theory and its relation to physical, object, and electron flow. We did that last week, but we'll go over it again. What are atoms, electrons, neutrons, and protons? We'll repeat that. The flow of electrons and how it is accomplished. What is the flow of electron called? Benny? Current. Yeah, we call that current. Explain electrical potential, current flow, resistance, and how they are measured. And these are the basis of using an ohm meter or a multimeter. So we'll talk about the 3 components of any electrical circuit. And you will need to know this, and it's very, very simple, not complicated at all. We'll talk about electrical power and how is it measured. Explain Ohm's law. Calculate potential. What is potential referred to? Voltage. They call it electrical potential. It's also voltage. Current, resistance, and electrical current using Ohm's law. Calculate the electrical power for circuit and the BQ hour rating for an electrical resistance heater. We'll talk about that as well. We'll take our time. We'll do a few examples. We'll do many examples. And there's a lot of solved example also in Blackboard. So pay attention. These are the terms we will go over. You don't have to write them down. I will repeat them at the end. But just glance through them so you can, when they come, you will kind of have an idea. Alternating current. Anatoly, what is that? AC. Amperes. Ampere is the unit to measure current. Atom, smallest part of matter. Compound, combination of more than one thing. Conductor, elements that conduct electricity. Current, that is the flow of electrons. Direct current, DC, so we have DC and AC. They're both currents, but they look different, and we'll see how. We'll talk about electrical energy, electrical power, electric pressure. Again, what does that look like? What's another name for electrical pressure? Electrical potential. Voltage. So voltage, electrical pressure, electrical potential, they're all the same thing. Different verbiage. Electricity, electrodes, electrolytes, electrons. So these are things that, just remember them, we'll go over them in details. More things, element, field of force. Elements are the smallest components of matter. Like hydrogen is an element. Field of force, if we have a magnet or current has a field of force where it's effective, otherwise it's not effective anymore. Free electron, remember that little electron, the last orbit that we can knock out between each atom, that is a free electron. Insulator, materials that do not conduct electricity. Kilowatt hour, that's what you pay for at the end of the month. Law of electric charges, we'll go over it. It means that similar charges repel, dissimilar charges attract, negative and positive attract, positive and positive repel. We'll talk about that and why is it important for us. Matter is things that build material. Molecule, a combination between 2 atoms. Is water a molecule or atom? Water.
Molecule.
Water is a molecule. Neutrons, stuff inside the atom that's neutral, in charge, they don't have charge. Nucleus, it's the center of the atom. Ohm, a good guy who invented a law that we're gonna use, and his law. Power factor, we'll talk about that, you don't need to do that now. And proton, it's whatever balances the amount of electrons inside the atom. More, resistance. What's the resistance? Something that opposes the flow of electrons. So we have the flow of electrons, and the resistance stops the flow of electrons. Seasonal energy efficiency ratio, SEER. You'll see that in a lot of equipment. Write that down. Static electricity. That's what we have in the winter. When you walk over carpet and touch the knob, that is static electricity. Volt. What is volt? Unit to measure voltage. Voltage, potential difference, electromotive force. All these three are the same thing, just different names. And watt at the end is the measure of power. What is the difference between energy and power?
Power is energy over time.
What helps create power?
Okay, and you said time. Yeah. So power is energy over time. How fast you spend that energy. Okay, we'll go over these terms at the end of the class to review after we explain each one of them. So electrical energy is used to maintain desired temperature. We can use electrical energy to heat the house. Did you ever use an electrical heater? Space heater? Those are cheap things you buy for 20 bucks. You turn them on, and they give off heat. How do they do that? So they run current through high resistance. And we said when we run current through a conductor, two things happen. First thing is the conductor will start to build up heat. Second thing, it will generate an electromotive forces around it. Well, a magnetic field, sorry. To have a field, a magnetic field around it, and also to have electricity. So, and basic principles of electricity must be understood by technicians to correct problems. What does that mean? So when I go, if I understand the circuit components, there is source of power, that's your receptacle here. There is resistance, that's what you're actually using. Loads are resistances. A light bulb is a load, it's also a resistance. And you know that you have current going through the circuit. And you also know that you need a complete circuit. So knowing these things will help you diagnose the problem. Yeah.
What's the difference between a compound and a molecule?
A compound, it's a general name for a mix of material. A molecule is one, say water. Water is a molecule. A compound could be a cement, water and mud and something else.
Okay.
Combination of a lot of molecules. It's too much information. We talked about this before. Again, you don't need to know that. Just for information, we talked about the atom structure, the nucleus, which is made up of proton and neutrons, that's inside the atom. Electrons, charges, orbits, the center, which is the nucleus. Protons, they have positive charges. Electrons, negative charges. And the hydrogen atom is the simplest atom, just for an example. What do you need to remember from this? Electrons are negatively charged, and the number of electrons equals the number of protons. And protons are positive. The reason that electrons stay is because they have something equal to their charge inside the atom. For example, if this is my nucleus, let's say it has 3 protons in it. How many electrons do I imagine to have around the 3? Yeah. So I'm going to have 3. First orbit is going to be 2, and 1 by itself. So the number of electrons is dictated by the number of protons. If I knock this thing out, what charge the element will be? Positive. Excellent. So it will be positive to have more ability to attract another electron because you threw it off balance. Okay. This is what it looks like. Hydrogen atom, two of them. And again, as we said, these are the orbits. So the first orbit is filled with 2 electrons, and that's it. Any more, it's going to go to a different orbit. Second orbit has maximum of 8, and this one actually has like 6, so it can be filled up with 2 more. Too much chemistry, we don't need to know that, but if you can focus on knowing the basics, electrons and protons, we're good. Any questions so far? Complicated?
A little bit.
If you just remember the electron part, you'll be okay. We're not going to be tested on that. Nobody will come to you and, okay, electrons and protons, okay, we'll remember that. At the end, if you just remember that electrons are negative charges, I'm happy. Okay. Too much information, we don't want this. Okay, electricity. One atom is charged, and there is an unlike charge in another atom. What are they trying to say here? So this example here, if I knock this thing out, it goes away. It can't get another electron. So what am I doing when I'm generating electricity? I'm basically pushing around electrons flow through the material. Those material has to have this ability to lose their last electron, and that's what makes them conduct. So think of water in a pipe. It's stagnant, doing nothing. This is your wire. How do you move the water around? Yeah, it's true. You can either like use buoyancy or you can pump it, right?
Yeah.
You put a pump, the pump is your current, so it's moving things around. The water is in the circuit, it's moving around. So this is what's happening. You can have this kind of analogy, it kind of makes sense. So water moving through the pipes, and every load in your house, whether it be a light bulb, a TV, is like a faucet. You take the
Turn it on, turn it
Yeah.
off.
So you take some of the circuit. If there is no pressure in the water, it will not move around. Okay? I will do a better like analogy of that. So if so water pressure is, what would that be for a circuit? The water pressure. Current, voltage, or resistance?
Current.
Are you sure? The pressure.
No, the pressure should be voltage.
Pressure will be voltage.
Oh, okay, yes.
The volume of water moved would be the
Okay.
amperage.
Water flow, how fast it moves, that will be current. Faucets or like taps, that will be what?
Resistance.
Resistance. Because it's consuming your pressure. The more pressure you have, the more flow you will have, and the more you can use in your sink. This is the law of charges, very simple, which means that positive loads, similar charges rebel, as you can see, and negative and dissimilar charges will attract. Now we remember that that's the law of charges. Question about that? Why do we need to know that? It will interact with magnetism. So when we have magnetism, we can use that to push things around. When you were little, you play with magnets, and you've noticed that you can put magnets together and they push each other, and you keep pushing because they are the same pole. If you flip the magnet, it will stick. So if you have two magnets, the same charge, usually they push each other away. You flip the north and south, it will attract. And we need to know this principle because it's important to understand the motor principle. How do we keep motor running? We keep changing charges back and forth. So flow of electrons, which is electricity, can be accomplished by a few things. Friction, and we talked about this last class, which is how do we generate electricity? 4 things. Either friction, or that's static. Chemical, produce electricity in a battery. So this is chemical. What about solar panels? This chemical or
Yeah, chemical.
chemical? You have silicon wafers with copper, and the heat make them use, the photons from the light makes me use electricity. Magnetic, this is called induction. This is where we use the law of charges. So produce electricity in a generator. And we'll talk about that at least for the next couple of weeks. How do we keep the motor running? I'm sure you have seen a motor running, a generator running. Your car alternator, how does it generate electricity? So your car alternator is connected with a belt to your engine. The engine turns the alternator, and by doing so, something is happening inside that's making electricity. And we gotta understand and know why is it doing that. And why is it called alternator? It alternate, and actually the alternate produce AC current, and it could be changed to DC. Question?
So, we were talking about solar.
Yeah.
So is that chemical or is that radiant?
No, it's chemical.
It's chemical.
It is chemical. It's a reaction to the photons, to the light.
So is it, so it wouldn't be radiant energy?
No, it's not radiation. There are some solar panels that actually use heat, but those are different. There are some solar panels that use the heat from the sun to produce electricity, like the
So
thermal pot.
radiant is more heat energy?
Yeah.
Okay.
There are other methods that are also used besides these. There are more chemical reaction. There are more like basically they stem from this, but there are different spin-off. Like the photovoltaic, it's a combination of photon reaction with the material and causing electrification. Static electricity is the oldest method of moving electrons. People start to think about electricity and charges, and we saw it also in thunderstorms. The friction between the clouds causes the electricity generation, and this charge keep building up until it can discharge at some point. Same thing when you walk wearing your fleece pajamas in a room in the winter when it's dry, and you touch the doorknob, it will spark. So it's the same thing. Permanently displaces an electron from an atom, takes it away, and it stays negatively charged or positively charged. Remember the balloon experiment when you rub up a balloon into your hair and let it go and it stuck to the wall? What happens? It gets stuck a little bit, then it goes away. So the negative charges that pull the balloon to the wall eventually equalize with the room and to fall off. It's not gonna stay forever. So it does at the end equalize, the flow stops. And usually it's caused by friction. And static is always there. Did anybody ever drive a truck? So what do a truck have sometimes? They have chains at the bottom to ground the trucks with the, sorry, if you drive a gas or oil truck, all the friction inside from the movement will generate a spark. So usually you want to prevent the statics by having a ground. If you fill a big tank, usually they tell you to put a static ground in it. In your car, when you fill your gas tank in the winter, they tell you, don't get inside the car and out. Why?
Increase. Yeah.
You can't, the friction you make in a new body, when you go and touch the nozzle, you might have a spark, and the spark can ignite the gasoline. I'm sure they have now means to mitigate that, but it's still there. That's why also the nozzle is covered by rubber and plastic. Yeah.
Are you talking about leaving the car on and?
No, but pumping gas and going inside the car and out, moving around, you might have a spark. So when you touch the nozzle, which is now mostly made out of rubber, so you prevent that spark. That spark with the fumes of gas can ignite. Hard labor, but it does happen scientifically. It could happen. Yeah.
I was gonna say, like, it's certain, like older gas stations and stuff that have been there for a while, there's still signs on the pumps that say to touch your hand to the top of your car
Yeah.
before you even grab the pump
Yeah,
to
yeah.
discharge any static.
Yeah, it depends on what you're wearing at that day. They don't know what everybody's wearing. What kind of charges do you have? This small little bud, it's strong.
Very big.
Yeah, it can ignite the fumes. And as you pump in gas into your tank, fumes are coming out.
Doesn't that mean you should always pump gas with your car off?
Yeah, you have to. It's a law. That's
Well,
something
yeah.
else, yeah.
Oh, that was crazy dangerous.
Okay, I'll give you 2 minutes to talk about it.